This is group number 2 from Engineering 141, Section 17. Our group members are Christian Bright, Graham McDonald, Harry Ustanic, and Charlie Hatchett. For our final project, we needed to construct a robot and use MATLAB code to use it to solve a Rubik's Cube. In order to do this, we needed to write our own algorithm that told the robot how to solve it based on a solution. To help with writing the algorithm, we constructed a flowchart to illustrate the necessary steps to solve the Rubik's Cube. In addition to the code, we made a website that detailed our progress from day one, including a calendar with all the due dates and weekly and daily updates.
We then had to create an algorithm that basically tells the robot how to manipulate the cube to solve one step and then how to reset the cube for the next step. The algorithm uses a loop that runs until all the steps are carried out. Within the loop, it uses conditional statements to distinguish which instructions need to be carried out based on what needs to be rotated on the cube. Nested conditionals are used to determine which direction the cube needs to rotate. Inside of our solution algorithm, we also have 3 separate functions that are used in order for the robot to determine what movement it needs to make. For example, we have a claw, a flip, and a turn function, each of which designates a specific movement for the robot. Here in the video, you see the Rubik's Cube being scanned. This is to determine what colors are on each face. From there, the solve cube function takes those readings and outputs specific steps in order for the cube to be solved. After that, the do solution function takes the readings and the steps, and it changes those into movements that the robot then carries out, and that's how the Rubik's Cube is solved.
Problems we encountered with the robot itself was specifying correctly to the motors on how exactly to move based on the power and the rotation amount. Our provided cube itself actually had very loose joints, so sometimes when the robot was handling it, it would overturn some portions of it, and that would sometimes cause problems. So we had to find compensations in our code to fix that.
If the cube is scanned correctly, the robot is able to solve any combination of turns, barring any technical difficulties previously mentioned.
Now sit back, relax, and watch the robot solve the cube.